This is the 2012 non-calculator paper, question 26. This table shows Jack's results for a 2-day canoe race. You can see day 1 and day 2 and the times are here. What was Jack's total time for the 2-day race? Pause the video and answer the question. Now what we're going to have to do, we've got 54 seconds and 56 seconds. We can add those first and then we can add the minutes together. So we've got 57 minutes and 59 minutes, and then we can add the hours together, 7 hours and 6 hours, and then we can get all those totals and add them together. So the total for the minutes, we've got 56 seconds plus 54 seconds is 110 seconds. And because there's 60 seconds in a minute, that means that we've got 60 plus 50 is 110, so we've got 1 minute 50 seconds by adding the seconds together. Now by adding the minutes together, we're adding together 57 minutes and 59 minutes. Now that is, if you just add one of these minutes, if you take one of the minutes from the 57 and add it on to the 59, you'll have 60 minutes plus 56 minutes. So that's the same as 1 hour and 56 minutes. We could have actually done the same thing up here. We could have taken 4 seconds from the 54 and added them to the 56 and got 60 seconds plus 50 seconds, which is 1 minute 50 seconds. So far we've added the seconds together and got 1 minute 50 seconds, and we've added the minutes together and we've got 1 hour 56 minutes. Now we can add the hours together. We've got 6 hours plus 7 hours is 3 hours. Now we have to add all of these totals together. So we've got to add the 13 hours to the 1 hour 56 minutes there, and then we've got to add on the 1 minute 50 seconds. Now if we add all the hours together, we get 13 hours plus 1 hour is 14 hours. If we add all the minutes together, we've got 56 minutes plus 1 minute, which is 57 minutes. And if we add the seconds on, all the seconds together, there's only this lot of seconds, which is 50 seconds, so we've also got 50 seconds there. So our total is 14 hours, 57 minutes and 50 seconds. Okay, this is the 2012 paper, question 27. Sarah bought 2 full bags of sand. Both bags had the same amount of sand in them. After she used 1/4 of one sand bag, she had a total of 35 kilograms of sand left. How many kilograms of sand were in 1 full bag? You can pause the video and attempt the question. Okay, now if we start off with 2 full bags of sand and then we use 1/4 of a bag of sand, then we will have 2 minus 1/4, which is 1 3/4 bags of sand left. Then we know that that 1 3/4 bags of sand is equal to 35 kilograms. So I'm going to actually draw that up. So I've got 1 full bag of sand here, and I've got another 3/4 of a bag of sand there. So what I've done, I've broken this bag of sand up into quarters, and this one into quarters. We've got a full bag here, 4/4, and we've got 3/4 here. So we're trying to work out how many kilograms of sand were in 1 full bag. So if 1 3/4 bags of sand equals 35 kilograms, and I'm representing the sand here with 1, 2, 3, 4, 5, 6, 7 quarters, basically, then we can just work out what 1/4 of the bag is. So 35 divided by 7 is 5 kilos. So each of these quarters is 5 kilos, and we can check that. 5, 10, 15, 20, 25, 30, 35. Yes, after using 1/4 of one bag of sand, there is a total of 35 kilograms left. So each section here is 5 kilos. So we've got, I'll just mark that in. So we can see here that a full bag will be 5 kilos times 4. So we've got 5 kilos plus another 5 kilos plus another 5 plus another 5. That's like 5 kilos times 4, which is 20 kilograms. So that's the answer, 20. Now for question 28 of the 2012 non-calculator paper. And the question is, write the answer to this division in the box. Pause the video and attempt the question. Now to do this question 12.24 divided by 0.12, when you're not using a calculator, we don't like dividing by decimals, so we really need to make this 0.12 into a whole number. And the way we would do that is to move the decimal point 2 places to the right and make this 12. And we do the same with the 12.24. We move the decimal point 2 places to the right, and it be 1, 2, and it becomes 1,224 divided by 12. This is the same as multiplying both the 0.12 by 100, and that makes it a whole number now, and multiplying the 12.24 by 100 as well, making that a whole number. So now the question becomes 1,224 divided by 12. So we can put the 12 out the front here, and now divide the symbol. So 12 into 1,224. Now 12 into 1 doesn't go. 12 into 12 goes once. Then we see that we're doing 12 into this 2 here. That does not go into 2. And so now we're doing 12 into 24. Sorry, I'll just fix that up. And as I was saying, 12 into 24 then goes twice. So our answer to this is 102. Okay, this is the 2012 non-calculator paper, question 29. And the question says, this diagram shows a common tiling pattern that uses squares and octagons. The dotted lines show the area of each octagon. Show that the area of each octagon is a multiple of the area of each square. The area of each octagon is 175 centimeters squared. What is the side length of each square? You may pause the video and attempt the question. Now, what I've done here, I've drawn an enlarged diagram of this octagon. Now, I'm just going to trace over the octagon here. Hit the first side, second, third, fourth, fifth, sixth, seventh, eighth. Now, we can see clearly that there are 1, 2, 3, 4, 5 squares in the octagon. So I've got 1, 2, 3, 4, 5 squares. And then we've also got these triangles actually. I've got 1, 2, 3, 4 triangles there. Now these triangles will be half the area of each of those squares. So in total, so what we can do, we know that we've got 1, 2, 3, 4, 5 squares. These two half triangles, because they've actually got the same base and height as these squares around them. So these two triangles will make one more square, and these two triangles make another square. So we'll just write that all down. So we've got the area of the octagon will be the same as the area of these 5 squares plus the area of 4 half squares or 4 triangles, which is the same as the area of 5 squares plus the area of 2 squares, which is the area of, same as the area of 7 squares. Now, we know that the area of the, so therefore the area of the octagon is the same as 7 squares. If the area of the octagon is 175, then the area of one square would be 175 divided by 7, which is 25. So I'll just fix that up. So if the area of one square is 25 centimeters squared, I won't put that in yet, then therefore the side length of the square will be the square root of 25, which is 5 centimeters. So the answer is 5 centimeters. So I've just written the answer in there, 5 centimeters, and I've actually added these units here, that the area of one square is 25 centimeters squared. This is the 2012 non-calculator paper, question 30. Jerry made this paper fan. He used 10 identical isosceles triangles. When the fan is open, its base forms a straight line. So here's the base, it forms a straight line. How many degrees is the angle marked A? Pause the video and attempt the question. Now I've just drawn one of the isosceles triangles here. Now we know that the base angles of an isosceles triangle are equal. So if this angle here is A, then this angle up here is A. So I've indicated that there. I've called this A, and I've just called this B. okay, just to give it some other name. So this angle in here, just in there, will be B. So we know that we've got 10 identical isosceles triangles. So therefore, if we look at the angles all in here, we've got angle B, 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 B. We've actually got 10 B's here making a straight line. And so therefore, B, this B here, actually I'll just draw it in on the diagram as well. So I've just drawn in 2 of the B's here, but all of these are B's, okay? So B will be equal to 180 degrees because there's 180 degrees in a straight line. So it'll be 180 degrees divided by 10, which is 18 degrees. So that means that this B is 18. So now using angle sum of a triangle, we know that 18, if this is 18 now, 18 plus A is 180 degrees because angle sum of a triangle is 180. And so if you add A and A together, you get 2A, and taking this 18 to the other side, we get 2A equals 162. And therefore, dividing both sides by 2, we get that A is 81. So our answer is 81. Okay, and I've put 81 in there. 2012 non-calculator paper, question 31. Kyle has some wooden blocks, the same as the one shown below here. He stacks them face to face to make a solid cube. What is the smallest possible volume of the cube? Pause the video and attempt the question. Okay, now we know that a cube has 6 equal sides. So if we look at the numbers 3, 2 and 1, they're going to have to be combined somehow to make a cube. But if we look at the lowest common multiple of 3, 2 and 1, well, it's 6. And also we know that 6, 3, 2 and 1, all those numbers divide into 6. So what would happen is that each side of the cube would be 6. So what I'm going to do, let's say I've got this rectangle here, and this is 3 centimeters by 2 centimeters, and we'll pretend it's 1 centimeter high. So 3 across, I'll add another 3 across. So these 2 3s make 6, and so far we've got 2 coming down. I'll add another 2 of these blocks there, and another 2 there. So we know that this is 3 across and 3 across, so it's 6 across, and we know that that's 2, 2 and 2, so we've got 6 down. We know but that the height of each of these is only 1 centimeter high, so we need to do this 6 times, stack it 6 times high. So therefore there will be 6 cubes on each layer and 6 layers high, which gives us 36 cubes in total. Now let's work out the volume of one cube would be 3 centimeters times 2 centimeters times 1 centimeter, which is 6 centimeters cubed. And therefore the smallest volume of the cube, because you've got 36 cubes in total, would be 36 times 6 centimeters cubed, which is 216 centimeters cubed. Question 32 of the 2012 non-calculator paper. This symbol is made from 2 circles. We can see the outside and the inside circle, and 2 lines. 1 line, 2 lines. And the circles have the same center C. The radius of the small circle is 3/4 the radius of the large circle, and the angle between the 2 lines is 60 degrees. So that's the angle between these 2 lines. The arc AB is 16 millimeters, so that's that length there is 16 millimeters. What is the length of the arc PQ? So we want this arc PQ in millimeters also. Pause the video and attempt the question. Now I've just put the solution up here. Now we say the angle QCP is 120 degrees, because if you look from A through C to X, this is a straight line. So therefore, we know that yes, that's 120 degrees in there, but that happens to be 2 times 60. Now the arc length AB, this arc length here is 16 millimeters. So arc length AX, sorry, the X was in the wrong position. So arc length AX will be 2 times 16 because the angle here is double the size of that angle there, or double the size of this angle here. So it'll be 2 times 16, which is 32. Therefore, the length of PQ will be 3/4 of 32, which is 24. And that is because the radius of the small circle is 3/4 the radius of the large circle. And I've just marked this information in on the diagram.